So as we've covered on numerous occasions, the first step in our process is look at the traffic to see if we can find anything that is suspicious. As you start looking through here, Wireshark's helping you out because it has all these red things over here. That's usually indication of a reset. So if we start looking through the traffic, you see there are lots of resets in this traffic. That's not normal. In a normal production network, you're not going to see this many resets. When you see these many resets, it's more than likely somebody's doing something trying to gather information. Because remember, a reset means something's not there. It's an abnormal close of a TCP connection. And when we start looking at this, we want to actually look at it from the approach of our methodology. Remember, the entire time we're learning how to hack and develop and learn these different types of techniques, we want to be able to analyze it at the lowest level. And that's the packets. And that's what I want you to understand. It's all about what's in the packets, not the tool. So you want to be at layer 2, layer 3, those types of things when you're doing your skill enhancement to learn how to do the different types of techniques to either do the hacking side or do the recovery from a hack. Okay, so what do we look at? Well, we look for open ports, and then we look for data, and then we look for sessions. And then we look for streams to see if any of the data has been used in any types of streams that's some type of an attack in most cases. So if you review this, again, there's many reset packets. So what we got to do is determine what's causing these resets. Again, it's a probable sign of a port scan, but we put in our filter, our flags.syn equals 1, and our tcp.flags .ack equals 1. So we've got them both, and we apply it. Now remember, these are all the ports that were open because of the response of the SYN and the ACK. That's what we're looking at here. So when you start looking, you can start making your list. 139, of course, the net bias ports. Got some 80 traffic, so we'll look at that. 135, more net bias. 21, so an FTP server. 1025, Microsoft messaging services. 445, more net bias. 1027, 1026, 1433, which is SQL. So there's some SQL traffic in here, right? Those types of things. So we can start going through here and we can look and see it's a repeated pattern. So now we know pretty much that's the only ports that were open that this possible suspect or whatever here it is, because we really don't know yet. But we know something's suspicious because we see all these different types of probing. So now if we go into one of these that we've got a SYN-ACK on and we follow the stream and there's nothing there, that means this was a scan. Now we got two types of scans. We have a connect scan, which completes the three-way handshake, and we have a stealth scan or a half-open scan, which doesn't complete the three-way handshake. And when you see this right here, the SYN-ACK, the ACK, and the reset ACK. So this completed the three-way handshake. So this first scan we look at right now in this packet 2111, 2011, shows us that we have a port scan. In fact, we have what's called a connect scan. Okay, so now we clear that filter and we put it and apply it again. And again, what are we looking for? We're looking at the open ports, right? So we got the 1433. That's always a good one to take a look at. So we apply this, follow the stream, and we see once again, this is a query of a probe and a port scan. In this case, it's the half-open scan. So at packet 1503, we have a SYN followed by a SYN-ACK, which of course is the target, and then the reset. Notice how it's a reset and not a reset ACK. The theory was with a stealth scan, it wouldn't be logged by the target. But today, pretty much all your detection monitoring devices know this, and they will detect these types of things. Okay, so now we've done this. So what's the next thing in our methodology? Well, remember, we look for open ports, and the next thing is data. To look at data, we do tcp.flags.push equals 1, and we apply it. This is all packets that have data in them. Now, everybody has different preferences, but my preferences, I've said before, I just use the bottom window, the data window here, and I start looking in this lower window to review the information, see what I want to investigate. And that's kind of how we do it. And we just scroll down, all right? So I won't go through every possible one because we've covered quite a bit of things on this, those types of things. So we've got some good information here, lots of different things, a lot of push, a lot of data. And I start looking through, and there's that version.bind. So now here I've got version.bind telling me that they extracted a bind version on that service. And again, remember, what we're looking for here is what did the potential suspect or attacker uncover with their scanning? Because the way the methodology works for an attacker, the way it works is they go for the live systems, Once they got live systems, they look at ports. Once they got ports, they look at services, what's running on those ports. And then they do enumeration, what's running on those ports, and can I log in and do the other types of things. In this case, we see we got Samba down in here. So again, that's our process. There's one more for you to look at. When you see a packet like this, a GET request packet as we're showing here, all right? So when you see that type of packet, it's manually entered. It's manually entered because that's all you have. Remember, if you're going to be doing this from a browser, you normally would see the actual type of browser and additional metadata here about the actual browser being used. So again, that's a manual probe that extracts the actual banner from a web server. In this case, it didn't have anything on it, which is good. So now we go back to our filter. Now remember, you can save these filters as well, so you don't have to keep doing this over and over again. And I keep looking at different things. So what am I looking for? Again, looking for things that look weird, suspicious. Right here we got Microsoft, some information about Microsoft, those types of things. And the best way to explain it, the OSCP, offline certificate services, those types of things. TLS, we're probably not going to be able to read the data in the TLS because that, of course, is encrypted. So since it's protected encrypting, we probably can't find a whole lot on that. So we're okay here. So we just keep going down. Let's go down here a little ways. And again, it's a process. You just apply this process and you practice, and you keep practicing it over and over again until you get better at what you're doing. All right. So we've seen some FTP traffic. So let's do a TCP.port equals 21. These are all our FT packets in the trace. All right, so we got some down here, and what I usually look for here is I look for the three-way handshake. So you see the SYN, you send the SYN-ACK, and the reset, right? So you're starting to look and seeing, is there any in here in the FTP that goes SYN, SYN-ACK, ACK? So I just scroll down a little bit here anytime I'm doing the analysis or forensics investigation, and I'm looking to see if it's going to change its characteristics. Now I do have something interested here that I might have to look at later, but I just keep going through and looking at the different things until I see a three-way handshake right here. See this? Goes a SYN, it goes a SYN-ACK, and ACK. There's the banner, the Microsoft FTP server. Now let's right click it, follow TCP stream. And now we have the user anonymous was allowed, anonymous access allowed, logged in, enter in passive mode, data connection ready, transfer starting. So now the perpetrator or the suspects uncovered that in this case, this network was allowing anonymous FTP. All right, so that means I can access. The weakness would be, can I do a write? So again, these are the types of things we want to do. So there's a lot of things we can do here. So if I do TCP.flags push again, equals 1, and I apply, I just look at the data. So again, it's just a process of following out a methodology, step-by-step methodology, and looking for data in the packets. All right. Now, one of the things we've always got the capability of is just recognizing immediately when something doesn't look right. In TCP, we have our 6 flags: urgent, ACK, push, reset, SYN, and FIN. Now, it's normal traffic to see certain flags set and abnormal traffic to see flags set that shouldn't be set. So when we go in here and we start looking, we're looking for some abnormal traffic. So what would be abnormal traffic? An open and a close. So a SYN and a FIN in the same packet should never happen. Because remember, the SYN is the first sequence, and you got a SYN and an ACK and those types of things. You never should have this. See how we've got a FIN, a SYN. Remember, a FIN is a normal close. A SYN or a synchronize is a normal open. So I've got an open and a close. Also, I've got a data, and I got the urgent pointer set. This is, in fact, here at 12944, this is a crafted packet. So that would be something to investigate to see if the crafted packet got any data back. But this one here is even better. This one at 12987 is actually FIN, push, and urgent. This is the classic signature of an XMIS scan using the Nmap tool. So we've uncovered all this information. So if you were doing network forensics on this trace, you know this person's doing lots of port scanning. All right, so they're doing port scanning. What do we say after port scanning? We do enumeration. So the data is identified with the enumeration. And then from there, we try to leverage and look for vulnerabilities. And that's kind of what we're trying to do when we're doing our hacking. So everything we've discovered so far shows the suspects using an Nmap tool to gather information from the network. Right here in 13207, if we come down here, we actually get the indication that is in fact Nmap. So if we come down to 13207, right here, how do I get that indication? Nmap scripting engine right there. It tells me it's an Nmap scripting engine. So when you're using an Nmap scripting engine, it's running all these different scripts by default, or depending on the perpetrator or the suspect, they could be running specific ones, right? So we know they're running that, and we've also got some web traffic in here. So one of the things we always want to do is we want to actually look at port 80 traffic. So let's do a TCP.port equals 80. Now this is all our port 80 traffic. As you can see, I'm starting to see profind here. This is all Nmap scripting engine stuff. The options command, all this stuff is Nmap scripting engine. And remember, really, the best way to look at the web traffic, I can apply another filter. And that filter is frame contains 200 OK. And now when I apply 200 OK, this is all responded to by the web server. And I just start looking for different types of things. And I said, okay, let's look at this. To follow a TCP stream. This shows me 200 OK, and it tells me the hacking tool Nikto was being used here. Now the nice thing is, they're not deploying any evasion tactics. So whoever this hacker is, if he's running a default Nikto scan, or he's not familiar with the intrusion, the invasions, and all the other stuff it can do. Now, my bigger concern from a security standpoint is right here. Microsoft IIS 6.0. It's not good that I got a Microsoft IIS 6.0 server in this trace, because there's been lots of vulnerabilities in Microsoft IIS 6.0. So again, we now know Nikto's being used. So what we covered in the past was, if I know a web scanner is being used, the best way to look at the web scanner traffic is to click on statistics. And then what I do is I go into HTTP requests, and there they are. And you start seeing, you start looking at some of these requests look kind of strange. That's because it's a scanning tool. In this case, it's Nikto. As you see, Nikto's doing all this cool stuff, right? All these different things it's doing. And as we load, we're loading more and more stuff. HT access, all those types of things. So again, a lot of information being used. As you see, it's still trying to load all the actual tool or traffic, because there's so much data there. And you see stuff that shouldn't be there. PWD, password, HT access. You shouldn't see that in your network traffic. So again, it's understanding what to look for. Okay, so you got the idea of that. Now, we've covered the majority of the actual types of things to look for. So if we go and we go to this packet, I just want to show you one other thing here. 15743. We just keep looking. Again, it's just a matter of looking through the packets and looking for the data. So in this case, I got a script command. This is Nikto using the script command. And I come TCP stream, and this is what you want to see. In this case, unauthorized. So even though they ran the attack, in this case trying to do a script command, it's unauthorized. But the bad side is, we still see Microsoft IIS 6.0, which is not good. So again, these are the types of things you can uncover when you actually look at different types of things. So if we go and we do our TCP.port equal. And what happens is, the more you do this, you get used to looking for patterns. Remember, all hackers follow some form of like a methodology. So we look in here and we start seeing some information. Some 1433 traffic, that's all port scan traffic. There's a three-way handshake, so we can take a look at that. Always look for the data, we can do that as well. Microsoft SQL server, so we see it's using a Microsoft SQL server, and we can extract information from that. Now, I've covered the solution here, and I got the index and those types of things. So again, what you want to look for is, where is that IIS box? So let's go look at that again. TCP.port equals 80. Yeah, and let's see, we got the send, ACK, so we got three-way handshake, we got the GET request, right? And it looks like in this case, the GET request is going to this 60. So let's see. Yeah, and we got a 200 OK, and we got Microsoft IIS 6. Now, from the standpoint of what we're doing here in our analysis and learning how to hack like a pro, now I know what an attacker is going to do is they're going to extract this information, and that's my vulnerable. So what I want to do is I want to filter just on traffic to and from that machine, because I know it is our weak machine based on what we're seeing here. So now this is all the 160 traffic. So now we start seeing, or sorry, the 60 traffic, host 60 traffic. So now we start seeing a lot of information going to and from that box. So what do we look for? Well, again, it's that process. It's just the same process we've applied over and over again. We look through here. I just like the lower window. People have different preferences, and we do different things, and we cover a lot of different information and how to do that. Now, I don't want to give away all the secrets because I want you to actually do some research and figure out some things on your own. So if I go here on this packet and follow the stream, it's a help. All right, so that's interesting. The client tool actually just typed in help. And you go see, and you start seeing you got some data in here, right? Unauthorized, all that type of things, scripts, negotiate, different things. And what was the one I said to look for? Frame contains. So if I do a frame contains 200 OK and IP.addr equals 192.168.177.60. So now I've set a filter that says, give me all the frame contains 200 OK and the IP address. So now I'll see if I get the data. And now I've got data. And I start looking down here, and now I start seeing more and more information that went to and from that machine. And from here, it's a matter of trying to put all this together and find out what's taking place, right? So there's no real magic key here. It's just basically take and look at a stream and look for the data. In this case, 404 not found. You're saying, well, why is it in there? Because if you keep going down, it's still extracting information. Resource can't be found. Right? As I scroll down, we got, again, Microsoft IIS 6.0. Nikto, this is all the Nikto scan stuff going on. All right? So this is all Nikto, all right? Different things. And information, the description. And again, as we keep going down, we've got more and more data to review. Now the trick is, and I showed this before, is when it's a database, start looking for database content. And in some cases, you'll be able to discover what the database content is. But in this case, since it's Nikto, more than likely it's just a Nikto scan. But you've got the idea. And I kind of wanted to give you this type of information now for this packet capture. So now it's on you to actually apply it. Explore more and build your own capture files. Remember, when you do anything related to hacking or any types of incident response, you want to always be able to look at it at the packet level. So start Wireshark, run your different attacks, and then review them in the protocol analyzer at the packet level. This is how you can learn to hack like a pro. And hack like a pro means you understand network attacks. You understand all these different things attackers can do at the packet level. A lot of people think it's running tools. It is not running tools. It's looking at the packets, understanding what the tools do on the network by analyzing those packets, and then you can create your own tool, or better yet, you can create and mimic a tool just by running data that matches that which you discovered in your protocol analysis. And that's how you learn to hack like a pro. Enjoy it and have fun. Thanks.